In this blog, we're discussing how we can evaluate the function calling capabilities of large language models. So this blog mainly discussed the fact that, again, now we're talking about compound systems, and what these systems are is when we are using LLM and allow it to use different tools to do multiple actions, hitting APIs, hitting APIs or other external tools. And instead of just being an LLM and that's it. So we try to add a lot of different components into these LLM applications. But in order for an LLM to be able to do function calling, it mainly requires three things. The first thing is to be able to interpret user requests accurately. What this means is that the user will give to the LLM a prompt, and the LLM needs to understand what it needs to do, right? The next thing is to decide if the request needs an external code. This is that the LLM needs to understand if it can handle this request on its own or it needs to go externally and get some information. And the last thing is how to construct a correctly formatting function call. As we know, like we humans understand how we need to go and hit different APIs, but the large language models don't. So the model needs to understand what is the need. Do I need to go externally or not? And if yes, how do I structure correctly this response, this JSON visual response, so that we can correctly go and hit the APIs and get the results we need? So with an example, let's say that we have this system prompt that we're saying you are an assistant who can use function calls to help you find the right answers to your queries. And you have access to several functions, right? And here we pass all the functions, which is the get weather, get time zone, and etc. different functions. And the user asks then to this LLM, so what is the weather in San Francisco? So in this query, the LLM needs to understand that it has to go externally to get this information. And it actually, given this question, it has to go and find the right tool, which is in this case is the get weather tool. Okay, so it needs to go.
Yeah, it decides I'm going to use that function that was provided to me.
Yeah.
Between all the functions that were provided to me, this is the most relevant one, which really makes the big difference between an agent or just a hard-coded, chain where you say you do that, then you do that. Here you give the LLM some wiggle room and decision like making.
Basically. The LLM needs to choose between the different tools it has access to. Yeah. Now, even if it chooses the right function in this case, let's say it understood, okay, I have to go externally and I have to use the get weather function, then it has to go and say, I need to access this function with these specific arguments because I want to get for the San Francisco and the region, let's say the state California. So given the question I'm asking, which is what is the weather in San Francisco, it needs to go and create exactly this is the call to the function, which is not easy to do, as you can imagine, right? So it has to infer what is the arguments of this function and give him a question, what is my first argument, and then what could the second argument could be, right? So this is not easy for the LLM to do. So the question here is, and let's say it did it. How do we evaluate that we did it, that the LLM used the right function and did it correctly? So for the sake of this blog, when we are saying function calling, we are meaning that the LLM is going and using one of the tools that is available. And the tool has access to the different functions and the different schemas and descriptions of those functions, usually described as JSON schemas. And what we're trying to do is when presented with a user query, the model needs to identify if any functions are relevant, and if yes, generate the right call to the function and then complete the necessary arguments. What we've seen in the field when it comes to using function calling in Databricks is that we have mainly two use cases, and one is these agentic LLMs, so LLMs who are used as compound systems hitting different external tools, or given some data that are coming into our platform in different formats, how can we use function calling to extract specific items from these documents and format them in nice JSON format so that then we can handle them nicely as JSON with specific keys and values. And this is what it is described here. So, for example, if I want to use an agent or an LLM in a kind of compound system with some agent calling, what it needs to do is, again, we have the user request, which is what is the projected revenue for this product in this fiscal year. Then the chatbot needs to go and understand that I will need to retrieve some financial data for this. We go and it has to go and understand that it has to go and hit this get financial data with specific parameters like the product, the start date, the end date, and the columns I need to calculate the KPI we want. And then either this is returned to the user as a JSON format so that the user can take it and hit anything externally. Or if the tool has the option to actually use this and hit an external API, then it goes, hits it, and then it is returned again to the chatbot to beautify it, to make it beautiful and return it to the user.
Amazing.
Mm-hmm. So that is an agentic application. And the other thing, as we said, is extract features in a JSON format from data. So data come in different formats, and we go through the document, extract text, and apply function calling so that we format it as JSON. And these are the two use cases. Now, back to the valuation frameworks. How do we know that in any of these use cases, the LLM does this well? So there are many different ways to benchmark this, and that is actually a challenge. But in this blog post, right, they focused on the Berkeley Function Calling Leaderboard and the Nexus Function Calling Leaderboard. So these two differ in the way what they are trying to capture mainly. So the first one, the Berkeley Function Calling Leaderboard, mainly focuses on these 5 things that the compound system needs to do, which is simple function, given that we are providing just one function to the LLM. Can the LLM understand, given the query, can the LLM go and hit this function? Now, if I pass it multiple functions, as we did in the example above, where we said get weather, get time zone, I'm passing multiple functions, can it go and select the best function amongst the ones I have given them in order to answer the query? The parallel function means that given just a simple function, I'm giving it one simple function, can the LLM understand that it has to hit it multiple times to get the final result? Whereas the parallel multiple function is a combination of parallel function and multiple function. So I'm passing multiple functions, and then the LLM needs to understand which functions to use and how many times it has to hit them, so it can hit them multiple times. Difficult.
So, for example, if I understand right, parallel function is just if I'm a user and I ask what's the weather in San Francisco, Paris, and London, and it needs to understand that it should hit it several times.
So I'm asking 3 different things
in parallel.
Yes. Okay. And then the relevance detection, this is something interesting that means that the LLMs understand where no function needs to be hit. Right? So don't force anything to a function. There are some cases where you can handle it on your own.
Got it.
Amazing.
Yeah.
And then they go through the strengths and weaknesses of this system, of this leaderboard, which is it has many categories, it is being widely accepted in the community, and it has this relevant detection, which is very key because not all the leaderboards have it. And of course, there are it's not too easy and not really easy to interpret it in the real world data and things like that. So there are always some things to keep in mind. So this is the first leaderboard. The next one is the Nexus Function Calling, which is a little bit different because instead of focusing on the actions the LLM needs to do, they have used some open source APIs, and they just use these widely used APIs and see what the LLM does. And these APIs are more difficult depending the API because some of them some of them have a lot of parameters that the LLM needs to understand. Some of them are very simple. Some of them they need to do kind of concurrent runs or concurrent hits. So depending the different APIs defined here, some of them are nested, so they have to do nested requests and things like that. So they kind of view it from a different perspective. However, the main point that this leaderboard, the Nexus one, has is that it doesn't capture this relevant detection, right? So it doesn't capture the case where the LLM actually doesn't hit anything.
Okay.
And here the strengths are that there is no saturation between any of the categories. And it's actually hard. It's a hard leaderboard. So especially the parallel calling one. So it's challenging even for big models like ChatGPT-4 and etc. So have a look at this. It's interesting to see how different these leaderboards are. However, one of the big...
It's useful to have it documented.
Yes.
It's useful to have it documented, the strengths and weaknesses.
Yeah. And one of the problems obviously here with these APIs is that the description of how to call this API needs to be very clear so that the LLM understands what this API is for and how to go and hit it. And some of these APIs are not well documented. So you kind of have to count on other people's work and documentation so that your function works well. And the last one is, as we said, that the relevance detection is actually missing. So they went and created all of these results across the different benchmarks, across the different models. And you can see here the results for each model. ChatGPT performs the best than Llama 3 in this in the BFCL evaluation. And it's kind of similar in the NFCL evaluation too, depending the different APIs being hit. The virus total nested one, the nested ones is the ones that actually a lot of calls need to happen to get the answer back. And as you can see, like most of the LLMs are failing hard in this one, because it's the most complicated.
Oh, and so Llama 3 is performing really well for this virus.
And this is Llama 3, the old one, right? Yeah, this is the old one.
Oh.
Yeah. And then they say they captured all the results, and they provide some points to take across so that you can improve the function calling capabilities of LLMs. And the most important thing is to have a very detailed system prompt that gives the ability to the LLM to understand what it needs to do. And you don't pass it through the context, but in the system prompt, explain explicitly what the model needs to do. And the next one is to direct the structure of the output we want using specific XML tags or specific JSON formats and etc. Actually, make sure you have a very strict format of how to create the output so that you parse it to a function call.
Simple question, but when you use agents like this, will you always get a trace of the agent's thinking and rationale when it made the decision?
Interesting. Unless you log it or you use something like ML flow tracing, where you can go and deep dive into what is happening behind each part, it's kind of black box, right? So you have to go into and start documenting that I'm logging this part, I'm logging this part, I'm logging this part.
Got it. To understand where did it go wrong.
Yeah. And the last thing is that, as we said before, you need to have very specific documentation of your functions, very explicit descriptions, and very explicit descriptions of the arguments, and also the data types and in what format we need those, so that we don't let the LLM reason a lot, like force it and fix it as much as you can. And few shot examples work well. So pass in your prompt some few shot examples of how to call these functions and what to expect as a result. Again, few shot prompting works well. And this gives you now the benchmark after the extra implementations or the optimizations they did. Last one, I want to they provide here the system prompt they used with all the different things they said to the LLM to do or not to do, right? So it's nice to go and read it. And you can reuse it. The most key points can be reused. Of course, you have to adjust it a little bit to your application. And then I want to just show you here the overall accuracy. So they did all the optimizations, and then they combined the benchmarks for all the models they saw. And now you can see the Llama 3, after everything, was the best performing model.
Very interesting.
And this is ChatGPT for Omni, right? Which is the new model. Interesting. So again, Llama 3, it was actually a very good model, and what we learn from here is that it can follow instructions and do function calling well, right? So maybe in other tasks, it's not that performant, but in this specific, in following instructions and for calling functions, understanding when to call functions and how to call them, it actually works very well.
Yeah, that really highlights the importance of understanding what do I want to do, because there's so many benchmarks. It's hard to follow. Well, it's easy to follow the leaderboard, but this is just a very generic leaderboard. So it's good to understand what is a leaderboard for a particular task, because this is an interesting result.
Yeah, and back to another discussion we had in another video on different models have different problems. Leaderboards are not consistent. Again, here we saw that you have to combine actual leaderboards and try to understand what you're evaluating, because you have to optimize for what you care and what you want to evaluate, and this is the right model for this.